All right, Adam, well, we get to be the entertainment for folks while they're eating lunch, and hopefully we can really share some more added insight to the AI action plan. And I know we have some really exciting stuff to dig into. A number of folks have talked about it already today, but we really haven't touched on the topic that I think you're most excited to key in on, and that's open source AI. So, again, the plan is fairly broad, but it really does focus on the efficient use of resources. So let's start there. Why is that theme so important for the federal government and our nation's success in adopting AI right now?
Yeah, so when you think about AI and training large language models, Sam Altman has been quoted saying that it costs over $100 million to train ChatGPT-4, and some estimates for the cost of training ChatGPT-5 have been in the range of $500 million per training exercise. So hopefully that's a budget number that strikes fear in all of our hearts, right? So most government agencies probably don't have $500 million to dedicate just to training an AI model. And so we really have to be much more efficient in how we're doing these things. I've also seen another quote that for every 10 to 50 queries you make to ChatGPT, 1 bottle of water is wasted.
Oh, man.
So if you think about the economic and environmental impact, we're seeing a lot of resistance these days to deploying more data centers in some of our rural environments. These people rightly don't want to have and live with the data center right next door. So when it comes to an efficiency perspective, we really have a lot of things pushing to make the most efficiency of the compute capability that we have.
I live in Data Center Alley in Loudoun County, so I could resonate with that in terms of not wanting to live next to any data centers anymore.
Yeah, it can be tough.
But let's dig deeper. Open source models are a way to kind of tackle that issue, and the communities that are kind of working through that, like Red Hat and others, are really driving innovation in that space. So tell me more about how that can help alleviate some of those issues you just referenced.
Yeah, absolutely. So, I think we're all aware of the role that open source technologies have played in our industry over the course of the last 20 or 30 years. And they've really changed from being a source of commoditization to the place where organizations go to innovate. And so we find the most innovation happening across the AI realm is really happening in those open source communities. And there's a couple that we're going to talk about, but specifically, the AI Action Plan very directly calls out open source models and open source weights as the preference for the United States government. And this is really interesting because what it does is it puts the US government, it puts our academic organizations, and it puts our industry right in the middle of what is really a global activity. And I couldn't be happier to see the administration make that strong endorsement, and it really communicates their understanding of the value that open source is driving in this space.
So Adam, we were chatting previous to this conversation, and anybody who understands the foundational models hears a lot about those large language models, and they've garnered a lot of attention amid the generative AI explosion, but there's also something that, frankly, you keyed me in on is those small language models. So what about those, and what are the benefits and why agencies might want to look in that direction versus the LLMs that we hear all too much about?
Yeah, so it's an interesting space. Excuse me, the land of the large language model versus the small language model. And just last month, NVIDIA released a new report saying that small language models are, in fact, the future of AI and agentic AI. So I would encourage you guys to find that report and look into it. The reality is that, if it takes $500 million to run one training instance of ChatGPT, then there's no capacity for government or any other agency or organization to begin to approach that. So what we find is that small language models give a lot of the ability of the large language models while requiring a much less significant compute resource. I like to liken it to the distinction between the World Book Encyclopedia that some of us grew up with on our shelves, and maybe I'm dating myself, as opposed to Webster's Dictionary. If I tell you that I'd like you to find the definition of a particular word, you can absolutely go to the World Book Encyclopedia and you can find an article that'll give you a summary of the definition of what that is. And it's going to be really comprehensive. But you're going to have to look through all of those books and maybe even look at the index if you remember that book that came with it. On the other hand, if you go directly to your Webster's dictionary, you're going to find the definition of that within that 1,000-page book, which is fantastic, and you'll immediately be able to return that. And so a small language model is very much like that. Whereas a large language model may be trained on the entire corpus of the internet, which is a massive amount of data, a small language model is going to be trained on a subset of that, and it's going to be much more able to answer that question quickly. The other side of that is that a language model in and of itself doesn't necessarily deliver value to you or your mission. So there's going to be additional training that you need to do in order to augment. We've talked about RAG and other capabilities for adding additional data to that model to bring domain-specific knowledge into that AI model space. And so with a small language model, you'll be able to do that level of training and augmentation much faster as well.
I love the the encyclopedia versus dictionary analogy. I think it's fantastic. And you're not dating yourself, because I also grew up with those on my shelf as well. So as we close out, Adam, how will the field of AI continue to evolve beyond, right now it's largely text and language based. There's some images and other multimodal things in there, but how will we get beyond that in those language-based models, and what will be the impact as that comes on board for federal agencies?
Yeah. So I think the most important thing, we heard a lot of talk today about data. Data is a fundamental part of AI. And the most important part of AI is going to be bringing your AI capability to your mission and where your mission is actually taking place. So rather than trying to bring all of that data back to a centralized data source, being able to execute a small language model in the space where your mission is happening is going to be incredibly valuable. So that's one place where edge technologies, small language models, and those things are going to come into play. But the other side of that coin is that where our mission happens is not exclusively in the domain of text. We find ourselves dealing with video, with audio. We find ourselves dealing with photographs, and a whole world of capabilities that simply don't make any sense inside of a text space. So I think when we think about AI, we need to think about AI as augmenting the human experience. So we understand some of that when it comes to the text space, but we also have the ability to bring RFID capabilities. We have the ability to use things like 3D cameras that can do plot generation in that space. And so as we move into this next world of AI, I think bringing a much more complete vision, quote, to that AI execution is going to be vitally important. And that's the thing that I would really encourage all of you to think about is, where can I take my AI workloads into what may traditionally be termed machine learning, but where can I take my AI workloads beyond the text space into a space that's much more representative of the human experience?
Well, I think those are great points. And it sounds like, from this conversation, when it comes to those models, bigger isn't always better. Small language models might be where the future is.
It is, and one of the things that I think is interesting that's coming out of open source communities is there's an open source project that came out of UC Berkeley, or maybe Santa Barbara, out of the UC system, which is called VLLM. And what VLLM does is it acts as an inference server in front of your AI. So inference is basically where there's smoke, there's fire, for example. And so it gives your language model the ability to learn something or come to a conclusion based upon partial data. But what we found is that these also have the ability to dramatically speed up the execution of large language models in the space. So obviously there's a lot of different parts. They're moving quickly, and there's a lot to learn. So thank you all.
Very exciting stuff. Adam, thank you so much. Let's give him a round of applause for some great insights.
Thanks.